So in this report, it introduces a few ways to calculate the time constant. So you can read this part. In particular, we introduce this one. So solve the equation of response using 2 points from the response curve. Suppose the response is of the form. So this is exponential decay, as you know. So you can choose 2 points, V and T are known, and solve for A and tau. And the report suggests that you can choose the 90% and 10% of total response. So for example, if the initial voltage is 10 volts and the final one is 0 volts, then you can choose 9 volt and 1 volt. And then the T for 9 volt and 1 volt. So this is one way to choose. So it should look like the following. So for example, this is 10, so you choose 9, and then you choose 1. So this is T9, and this is T1. So by using these values, and then you can solve the equation to obtain the A and the tau. Okay, so now we move on to 1D. So 1D, it says that after the switch has been in position 2 for a long time, switch to the position 1 and then record Vc for every 15 seconds. Also, you have to determine the time constant from the graph and then calculate the ideal time constant using the nominal values and then find the error. So this is the first procedure. The procedure 2 is RL circuit. So RL circuit, so using your multimeter measure. So first you have to measure the 100 millihenry inductor and then measure its DC resistance. And then compute the maximal time constant. So you don't need to really focus on what is maximal. So you can just measure the time constant for this inductor. It is fine. And then do you think you can see the change of current with time with your multimeter? So usually the DC resistance for this answer should be, for example, 120 ohms. So that the time constant should be small. And then it is a little bit difficult to observe the change of current.